We've been told that the path to true artificial intelligence is paved with more data and faster processors. But what if the biggest breakthroughs have nothing to do with computational power? The real secret might lie in teaching AI not just to learn, but to dream. In this video, we'll explore the final frontier of AI, moving beyond systems that follow commands to ones that process a genuine creative urge to ask, what if? In previous videos, we started this journey by exploring the most powerful and overlooked tool that we have, which is the human imagination. And this led to a profound realization. Our minds aren't just passive file cabinets for memories. Instead, they act as creative workshops, constantly taking memories apart and then reassembling the pieces into entirely new but believable experiences. And then we saw how this applies to more abstract ideas. This powerful cycle of experiencing and remembering and recreating and then reimagining is the engine of human creativity. Our entire conscious awareness is built on this ability to combine and layer these self-generated thoughts. This process of creating something new from the building blocks of what we already know is the foundation of our discussion today and the key to unlocking the next generation of artificial intelligence. This combination of these self-generated experiences helps shape your thoughts, ultimately forming your entire conscious awareness. It might seem surprising to claim that all thoughts stem from memories of past experiences. But once you recognize that you can both recall sensory observations and reflect on your internal thoughts, that initial skepticism fades away. If you've been following this train of thought, you might have an idea of how to integrate imagination into artificial intelligence. A computer can catalog its observations, and it can later recreate them in its mind, similar to a type of digital hallucination. It also has the capacity to hold on to these newly formed ideas. The crucial aspect is establishing a relationship between its cognitive processes and their initial inputs. This connection allows the machine to not only generate new concepts, but also to explore them in depth. Now, let's explore how this might work in an artificial intelligence system. Picture a network that mimics the way that our minds process information. At its core, there's a loop of information flow similar to how our brains work. When sensory information comes in, whether it's visual, auditory, or any other type of data, it follows two distinct paths. The first path leads to immediate actions, much like our reflexes or our learned responses. These are straightforward connections. Situations lead to action, clear and direct. But there's a second path where the system can generate thoughts about what it's experiencing. These thoughts aren't just stored away. They're fed back into the system as new input, creating a continuous loop of processing and reimagining. This feedback loop is crucial. It's what allows the system to not just respond to information, but to actually work with it, combine it, and to create new patterns and possibilities. Think of it like a river that splits into two streams. One flows directly to a destination, while the other circles back to join the main flow, bringing with it new elements and new possibilities. This circular flow of information where thoughts become new inputs for more thoughts is what could give AI systems the ability to imagine and create, much like our own minds do. This architectural approach moves us beyond simple input-output machines towards systems that can actually engage with information on a more creative and human-like level. It's a step toward artificial intelligence that doesn't just process, but truly thinks and imagines. A technically sophisticated observer might recognize the parallels between this concept and recurrent neural networks, enhanced by the ability to merge diverse ideas into a unified entity. For instance, the AI comprehends and interprets the intricacies of a skyscraper and ocean depths independently. This enables it to visualize each concept distinctly. When presented with a sentence that intertwines these two elements, the AI skillfully integrates the ideas, demonstrating a cohesive thought process. This process mirrors human cognition. We don't just perceive objects in isolation, we connect them, cultivating a richer and a more nuanced understanding of the world around us. To cultivate the skill of imagination, we must have more advanced algorithms. These algorithms must allow the AI to store information about individual objects while promoting creative combinations of this knowledge. For instance, when encountering the phrase, "a skyscraper beneath the waves," the AI would tap into its visual database, the one filled with depictions of urban structures, and another that encapsulates the mesmerizing beauty of underwater landscapes. So let's look into how an AI system can develop understanding in a manner similar to our own. Picture a learning journey where the AI first encounters and grasps individual concepts independently, such as skyscraper and deep ocean. Initially, each concept is understood in isolation, forming unique mental models. When the AI encounters a skyscraper, it absorbs the essence of modern architecture: the shimmering glass architecture, the towering heights, the interplay of sunlight on its surfaces. In parallel, as it delves into the ocean's depths, it comprehends the fluid dynamics of shifting currents, the dance of light reflecting through water, and the graceful movements of marine life. These insights serve as essential cornerstones in the AI's database and its knowledge base, akin to rich entries in a vibrant and evolving lexicon of experiences. The true enhancement unfolds when the AI begins to fuse these distinct concepts. Upon encountering the phrase "skyscraper under the sea," it doesn't merely retrieve these memories in isolation, it constructs a new integrated mental model. The AI synthesizes its grasp of modern architecture, complete with urban characteristics, alongside its insights into oceanic settings. This results in an innovative concept that exceeds its initial understanding. This capability to blend discrete ideas into fresh and meaningful combinations transcends mere storage and retrieval of information. It emphasizes the interaction and the fusion of elements in ways that might not have been directly taught. This reflects how an AI system can evolve from basic pattern recognition to genuine imaginative thinking, much like our own cognitive process. The AI generates new opportunities by intertwining these learned concepts, all while preserving the core attributes that make each element both recognizable but also significant. Now, this forms the bedrock of artificial creativity, the capacity not only to learn, but to reimagine and recombine ideas in original ways. Thoughts must fill a specific function. Enabling an AI to visualize sounds and sights is merely the first step in nurturing authentic creative imagination. For thoughts to be genuinely creative, they should address both the actual and the hypothetical challenges. As mentioned previously in this conversation on awareness, memories are formed when they contribute to solving contemporary issues, either by raising questions or offering solutions. Additionally, thoughts acquire importance through their broader relevance. An AI can identify patterns from its experiences and then generalize them when beneficial, preserving essential elements while discarding superfluous details. An AI holds memories primarily when they help in solving problems, and it transforms recurring patterns from its experience into coherent knowledge. This process guarantees that its thoughts remain practical, rooted in reality, and significant. The thoughts generated by such an AI are much like our own. They follow recognizable patterns, and they reflect a synthesis of past experiences, which anchors them in the real world. So, for example, let's take the earlier skyscraper example, where a contemporary building is whimsically imagined on the ocean floor amidst schools of fish. This imaginative portrayal, albeit surreal, retains a connection to reality as skyscrapers, ocean depths, and marine life all coexist. As you weave together and layer thoughts to generate new ideas, the link to reality may become tenuous. The challenge lies in discovering a sweet spot that balances being firmly rooted in reality for relevance while still allowing enough creative freedom to innovate. Memories and thoughts are linked as two aspects to the same self-generated experiences. Now, this raises a crucial question. How does one learn to associate particular scenarios with imagined concepts? In an upcoming video, we're going to explore the intricacies of memory formation and its implication for AI systems. So where does this leave us in our quest to create truly imaginative AI? Now, the answer lies in understanding that imagination isn't just about combining random elements. It's about creating meaningful new experiences from the building blocks of memory. Just as your mind can make a building or an underwater scene or schools of fish and weave them together into a cohesive scene that feels both impossible but somehow natural, tomorrow's AI systems need to do more than just process data. They need to dream. When we let go of the notion that artificial intelligence must be built on rigid databases and perfect recall, we open the door to something more powerful. AI systems that can truly create, imagine, and innovate. Systems that don't just remember, but reimagine. Systems that don't just analyze patterns, but weave new patterns of their own. The future of AI isn't about building bigger databases or faster processors. It's about understanding and replicating the beautiful dance between memory and imagination that makes human consciousness so remarkable. By teaching machines not just to store experiences, but to play with them, combine them, and transform them into something new, we might just unlock the key to genuine artificial creativity. Remember that beach scene you imagined at the start of your journey? That simple act of mental creation, combining waves and seagulls and footsteps into a holistic and seamless experience, holds the blueprint for the next revolution in artificial intelligence. Now, you might be thinking, wait a minute, AI can already create underwater buildings and flying cars and images and videos of whatever else we can even imagine. And you're right. Modern AI can generate incredible images that blend different concepts together. But here's the thing. There's a crucial difference between following instructions and having the urge to create. Think of Pablo Picasso for a moment. So he said that good artists copy and great artists steal. Now, what did he mean by that? He wasn't talking about plagiarism. He meant that truly great artists can take inspiration from another artist so completely that they make it their own. They transform it into something entirely new that's theirs. Before Picasso created his revolutionary abstract style, he could paint traditional portraits that look just like classical portraits. He could paint you and he could put life into it. He mastered the rules and then he broke them. And that's what made his later work so powerful. And this is what separates current generative art. He was breaking them with purpose. He was building an entirely new form of art, having mastered the old. What if we tried something completely different? That's when we'll know we've created something truly intelligent. Not when it can create what we imagine, but when it can imagine things that we never thought to create.